Hey guys, so in this video we're going to talk about problems where we have multiple wheels or objects like wheels such as cylinders or discs or gears. And when we have multiple of these things chained together, connected to each other by either a chain or a belt, much like a bicycle. Let's check out how these work. So these problems where we have two, it could be more than two, but it's almost always two, wheel-like problems. So when I say wheels, I mean things like discs, cylinders, etc. They're pretty common in rotational kinematics, so let's check them out. There's two basic cases, and we have a case where the wheels are rotating around a fixed axis. In other words, you have something like these two wheels here. Imagine that there's a chain around them, but this wheel is bolted, let's say, to the wall, and this wheel is bolted to the wall. So if they start spinning, they're not going to move sideways, okay? So in this case, we have W, because it's going to spin, but the wheel itself, there's a W, let's call this W1, and then there will therefore be obviously a W2 here. But this wheel will have no velocity of the center of mass. This point doesn't move sideways, okay? It does not move sideways. Same thing with this point, VCM2 doesn't move sideways, okay? So there's no velocity of the center of mass. An example of this is if these were pulleys or gears that are, like I said, attached to the wall. The example I gave you earlier is a toilet paper that's fixed to the wall and it rotates around itself like toilet paper usually works. The other one's a static bicycle. So there's two basic ways you can have a static bicycle. One is you lift your bicycle from the floor, and then if you spin the wheels, guess what? The rotation of the wheels doesn't cause the bike to move sideways because it's basically now fixed. It's not free to move. The other way is if you flip your bike upside down. So basically, if the wheels are not touching the floor, it's a free axis. It's a free wheel. Okay, and then in other cases, we're going to have situations where two wheels are connected and they're both free to move. And that's a bicycle, right? As the wheels spin, they spin together. So we're going to look into that later. All right, so the big thing to remember, the big thing to know here is that whenever a chain connects to two wheels, or connects two wheels, we have that the tangential velocity at the edge of one wheel equals the tangential velocity at the edge of the second wheel. So let's pick a point here and a point here, and I can say that this VT equals this VT. They're all the same. Okay, so VT1, VT2, VT2 is the same as VT1. In fact, you could pick a point anywhere, and because it's the same chain, the velocity, the tangential velocity has to be the same. Now remember also that when you have a fixed disk, so let me write this here, for fixed axis, remember that VT equals R omega. The tangential velocity at a point away from the center, Vt, is given by R omega. In this case, we're talking about 1, so it's R1 omega 1. Okay? So this guy here, for example, would be R2 omega 2. Now, the Vt's are the same. The Vt's are the same, but, so that's good. But the R's are different. R1 and R2 are different. The wheels have different sizes. Therefore, because these guys are different, then the omegas will be different as well. Okay? The R's are different, so the angular speeds will be different. In fact, the greater my R, the smaller my omega, and vice versa. If you got a tiny wheel and a big wheel, the tiny wheel will spin much faster while the big wheel is slowly spinning. Okay, so there's an inverse relationship there. All right, so V1 equals V2 and V equals RW, so we can write this. We can write that VT1 equals VT2, so R1W1 equals R2W2. This is the big equation for this video, the most important one. Now, what I want to do is I want to show how there's three variations of this equation. Okay, and that's because we not only have W or omega to talk about to describe how quickly something spins, we also have frequency, period, and RPM. All four of these are useful in describing how quickly something spins. So I'm gonna replace W with F, T, and RPM, and this is gonna generate different versions of this equation. So W is 2 pi F. It is also 2 pi over T. And remember, frequency is RPM over 60. So I can also say that W is 2 pi, and instead of F, I'm going to say RPM over 60. Okay? Can you see that? Yes, you can. All right, so we got these versions, and what I'm going to do is I'm going to replace W here with this, and this. Okay? So R1, instead of W, I'm going to write 2 pi F1, and then R2, 2 pi F2. What happens is the 2 pi's cancel, so you're left with R1, F1, R2, F2. Okay? If I were to do the same thing with these other guys here, I'm going to do this one more time. If you were to do this with 2 pi, you would get R1. I'm sorry, if you were to do this with T, you get R1, 2 pi T1, R2, 2 pi T2. The 2 pi's cancel again, and we're left with, let me put it over here, R1 over T1 equals R2 over T2. And then the last piece is with RPM. And I would do the same thing. I'm going to just kind of skip here for the sake of time, but I'm going to say that you can have R1, RPM1 equals R2, RPM2. The most important of these four is the first. The other three are just sort of derivative, equivalent, similar versions of them. But I find that if you know all four of them, you're best suited to solve these problems very quickly. Okay? These problems are very straightforward. This is the basic idea. When you have two connected wheels, these four equations will work for you. So let's do a quick example here. I got two gears of radius 2 and 3. So let's draw this here. R1 equals 2, the little one, then a bigger one, R2 equals 3. And they are free. They're free to rotate about a fixed axis, okay? Now, a little tricky here. Remember, I talk about fixed axis and free axis. So even though I use the word free here, they're free to rotate about fixed axis. So these are fixed, okay? Which is what we've been talking about, which means the velocity of their center of mass is 0. What it also means is that R1 omega 1 equals R2 omega 2 and all the variations, okay? All right, so it says here when you give the smaller pulley or gears, let's just rewrite this. These were gears, not pulleys. When you give the smaller gears 40 radians per second, it doesn't tell me which way, so I'm just going to spin it this way. I'm going to say that W here is 40 radians per second. All right, I want to know what is the angular speed, so this follows this way and then it spins this way. So if this is W1, what is W2 that the larger one will have? Very straightforward. These are two connected cylinders, so all I got to do is write the equation for them. R1 omega 1 equals R2 omega 2. We're looking for omega 2. So omega 2 is R1 omega 1 over R2. Just solve the equation. This is 2 over 3, and omega 1 is 40. So the answer is going to be 26.7 radians per second. All right? That's it for this one. Very straightforward. Let's check out the next example.